Right. Yesterday we have discussed these three problems. Matrix A m cross n, B n cross P. Then the number of multiplicative operations and additive operations are needed to calculate matrix AB are MPN and MP n minus 1. Right? Based on this problem, we have another previous gate question, 2013 gate question, similar problem, but extension of your previous problem. In your previous problem, you have two matrices A and B are given. Here we have three matrices P, Q, R. Okay? Now concentrate. Yeah, definitely, Yogeshwar. Noted all your personal queries, all the remaining queries at the end of the class. Okay? First, concentrate on the content. What is the minimum number of multiplications involved in computing the matrix product PQR, where matrix P has 4 rows, 2 columns, Q has 2 rows, 4 columns, R has 4 rows, 1 column. Observe P, Q, R. One student is multiplied P with Q with R. Another student is multiplied P with QR. First student is multiplied first PQ, then with R. Next student is multiplied P with QR. Whether first you multiply PQ, then with R, or P with QR, product PQR only. Okay? Now, sir, what is P? P is 4 cross 2. Q is 2 cross 4. R is 4 cross 1. 4 cross 2, 2 cross 4, 4 cross 1. Let me explain the logic. Those who have joined now, I have not explained anything. This is the first problem. Okay. Now, observe. The problem is designed on a simple logic. Matrix A m cross n, matrix B n cross B are multiplied. If both A and B are multiplied, the resultant matrix is AB of order m cross P. To create m cross P, how many number of multiplications are required? Means M, P, N. Understood? M, P, N. Same logic I am going to implement. Okay? This logic I have explained in the previous class. Now, come here. One student is multiplied P with Q. First PQ, then with R. Okay? Now, first 4 cross 2 multiplied with 2 cross 4, the result is 4 cross 4. 4 cross 4. To create this 4 cross 4, how many number of multiplications that student has applied? Observe. M, P, N. 4 into 4 into 2. 4 4 ja 16, 16 2 ja 32. Next. After getting PQ, then he has multiplied with R. Now, PQ then with R. PQ is 4 cross 4. R is 4 cross 1. The resultant matrix is 4 cross 1. To get 4 cross 1, how many multiplications he has applied? 4 into 1 into 4. 4 into 1 into 4. Formula MPN. M P N. 4 into 1 into 4. That is 4 4 just 16. 32 plus 16. 32 plus 16. 48. 48. Understood? First student has applied 48 multiplications to get PQR. Now another student is multiplied first Q with R. Observe, to get QR of order 2 cross 1, how many multiplications the student has applied? M P N. 2 into 1 into 4. 8. Okay. Now later he has multiplied with P. P is 4 cross 2. 4 cross 2 multiplied with 2 cross 1. Result is 4 cross 1. But how many multiplications he has applied? MPN. M 4. PN. 4 into 1 into 2. That is 8. 8 plus 8. 16. One student is applied 16, another student is applied 48. So which one is correct? Shall I take 16 or 48? 16. Not both. You have to take 16. Sir, why it is so? In the problem they have questioned minimum number of multiplications. Minimum number of multiplications. That's why answer is 16. Understood? So you have to remember this logic. Which logic? MPN logic. That is the short trick. If you remember MPN, you can able to solve the problem very easily. Rahul, I have covered this concept yesterday. You watch the recorded video. Next problem. Observe here. An n cross n array V is defined as follows. V ij equal to I minus j for all ij. Janaki, whether 3 matrices are given, 4 matrices are given, logic is 2 cross 2 logic only. MPN logic. Okay, now come here. An n cross n array V is defined as follows. Vij equal to I minus j for all ij. Then the sum of elements of the array. You need not to take n cross n matrix, n cross n array. Just you take simple 2 cross 2 matrix. Based on that, you can estimate. Suppose V is a 2 cross 2 matrix because V11, V12, V21, V22. Given that Vij equal to I minus j, I means row, j means column. 1 minus 1, 0. 1 minus 2, minus 1. 2 minus 1, 1. 2 minus 2, 0. Now, the sum of the entries of the array, 0 minus 1 plus 1 plus 0, finally 0. So, the sum of the elements of the array is 0. Sum of the elements of the matrix. Yes, it is Q symmetric. That's why sum of all the elements are 0. Okay. Now, observe the problem. The number of different matrices that can be formed with the elements 0, 1, 2, 3. Each matrix having 4 elements is. Observe. Here it is a problem designed based on counting. So the number of different matrices, you are going to generate different matrices with how many entries? 4 entries. 0, 1, 2, 3. Whether answer is B, C, or D, doesn't matter. First, understand the concept, how to calculate. Okay? Definitely, I will conduct the poll. Let me explain. The number of different matrices that can be formed with the elements 0, 1, 2, 3. You have only 4 elements. With the help of 4 elements, how many different matrices you can generate? That is your question. Okay, so in the problem, is there any hint about order of the matrix? Whether the matrix is square matrix or rectangular matrix, is there any hint? There is no hint. So you can arrange either rectangular or square matrix, whatever it is. How many different matrices you can generate with these 4 entries? That number of matrices you have to write. Okay, writing matrices consumes time. That's why apply the logic. Simple logic you have. Observe. You have 4 entries. Yesterday I have given the definition. A set of mn numbers can be arranged. M rows into n columns is known as m cross n matrix. Therefore, 4 elements can be arranged either 1 cross 4 form or 2 cross 2 form or 4 cross 1 form. How many different ordered matrices you can generate? How many matrix means repetition is allowed, man, Abhishek? So such type of doubts you are getting. 1, 1, 1, 1 is not a matrix. Concentrate. You have only 4 elements. 1 cross 4 or 4 cross 1 or 2 cross 2. These are the 3 different types of matrices you can generate. In each type matlab, in 1 cross 4, 1 row and 4 columns, na? 4 columns. In 2 cross 2 matrix, you have 2 rows and 2 columns, so 4 entries. In 4 cross 1 matrix, you have 4 rows and 1 column, you have 4 blank places. So the logic is, whether rows or columns doesn't matter. Here, 3 different types. In each type, you have 4 blanks, 4 blank places, 4 blank places. Each blank place, each blank can be filled. Each blank can be filled in how many ways? In 4 ways. So there are 4 blank places. Each blank can be filled 4 ways. So 4 into 4 into 4. 4 power 4 ways. How many types of matrices you have? 3 different types. 3 different types. Therefore, 3 multiplied with 4 power 4. Understood? Now, 3 into 4 power 4 is the answer. Because in the problem, he has not mentioned the order. Prashant, no problem. Yesterday only have started this batch. You can continue. Matrix means repetition is allowed. Shivam. Observe this problem. The number of different, अगर ऑर्डर दिया है तो ये प्रॉब्लम ऑर्डर दिया, you solve this problem. The number of different n cross n symmetric matrices, here n cross n, first condition, symmetric, second condition, different, third condition, every entry is being 0 or 1, fourth condition. You have 4 conditions. Okay, Sanju, even though you are lateral entry, no problem. I am explaining slowly. Okay, try to understand the logic. Don't look at the comments. Concentrate on the content. You need not to write the notes. Just download the PDF copy after completion of the class. Concentrate on the explanation. Okay. In this problem, why I am giving all these hints, you have to think in that direction. Your thought process should go in that direction. One by one, you have to fulfill the conditions. Okay. First condition, matrix must be n cross n. Second condition, symmetric condition. Third one, every matrix must be distinct, different. Every entry must be either 0 or 1. How many such type of matrices you can generate? Not able to click the concept, don't worry, I am here to explain. Okay, I'll explain 2-3 methods. Very good, excellent problem. In this problem, you can solve this problem either by using options or by conventional approach. First, I am explaining the problem by using options. Okay, concentrate. While I am explaining, just you concentrate. Whether it is wrong or right, whatever answer you got, whether C or D, I'll give the clarity. Okay. Some students has marked it as D, last option, but I have changed the original problem, last option to third option. Okay, I have changed the options. Now observe. First, they have given conditions. First condition, your matrix must be symmetric. You have to fulfill that condition first. Next, square. First one is square. One is square matrix. Second one is symmetric. Third one is distinct. Fourth one is either 0 or 1. Okay, now come here. There is no lag. Refresh your systems. Concentrate here. I am not going to take n cross n matrix. Just I am going to take simple 2 cross 2 matrix. Okay. Video blur. Now okay. Now observe. I am not going to take n cross n, just I am going to take 2 cross 2. Observe here. In a 2 cross 2 matrix, yeah, I have fulfilled for first condition or not? N cross n, 2 cross 2, fulfilled. Next, symmetric condition. Sir, when we will say a 2 cross 2 matrix is symmetric? Tell me now. When we will say a 2 cross 2 matrix is symmetric, very good, A equal to A transpose. In the case of matrix, I am talking about elements. The elements must satisfy the condition Aij equal to Aj. Concentrate here. A12 must be equal to A21. This is A12. This is A21. A12, this is A21. These two entries must be same. Same. Not similar, same. If you fill with 0, you have to fill with 0. If you fill with 1, you have to fill with 1. Understood? When you maintain those two entries are same, automatically your 2 cross 2 matrix would be symmetric. Okay? Now, that's why I am going to treat A12 and A21 as a single blank. Understood? Sir, two places you are taking as a single blank. Why it is so? Entries of A12 and A21 are same. Those two blank places you have to fill with same entry. That's why I have treated as same. Okay? Next. Sir, what about leading diagonal entries? What about other two blank? I am coming to that. You wait, just wait. A11, one blank. A22 is another blank. Okay. Now, how many blank places you have? 3 different blank places. So I have fulfilled symmetric condition and distinct condition. Yes, I have taken 3 distinct blanks. 1 blank, 2 blank, 1 2 and 2 1 are combiningly one blank. Now, entries either 0 or 1 I have to fill. So this blank I can fill either with 0 or with 1. Either 0 is present or 1 is present. So 2 possibilities. Either 0 or 1, 2 possibilities. Either 0 or 1, 2 possibilities. Total distinct means different. Prashant is different from Saurabh. Saurabh is different from Mishra. That is called distinct. Okay? Concentrate. 2 into 2 into 2. 2q. 8. So, answer is 8. When matrix is 2 cross 2. Okay? Matrix is 2 cross 2. I am explaining how distinct is fulfilled. Concentrate. Sir, how it is 8? Simple. Earlier I have explained logically. Now I am explaining with entries. With entries, if I explain clearly, you will get the idea. Sir, what is distinct? First, I have to fulfill symmetric condition. 2 cross 2 is over. Next, symmetric. If I fill with 0, I have to fill with 0. If I fill with 0, I have to fill with 0. 0 with 0. 0, 0. 1, 1. 1, 1. 1, 1. 1, 1. Symmetric. Symmetric matlab A12 and A21 must be same. Sir, remaining 2 entries I am going to fill now. 0, 0, 0, 1, 1 0 1 1, 0 0 0 1 1 0 1 1. ये भी क्वेश्चन मार्क है क्या? All are distinct or not? Either 0 or 1. It is not our choice. It is given in the data. It is given in the data. They have given either 0 or 1. It is not our choice. Okay. Now, how many distinct? 8 distinct matrices. 8 distinct 2 cross 2 symmetric matrices. 8 distinct 2 cross 2 symmetric matrices with each element being 0 or 1. Now come to the problem. Options. In the options, in the place of n, substitute 2. Sir, why we have to substitute 2? Actually, problem is given n cross n. You have solved 2 cross 2. That's why you have to substitute 2. Okay. Now, 2 square, 4. But your answer is 8. That's why eliminate this. Next. 2 power 2 square. 2 power 2 square is not 8. Eliminate this. Now, 2 power 2 square is 4. 4 plus 2 by 2. 2 power 3. Because 6 by 2, 3. Therefore, 2 power 3. Okay. Now, 2 power 2 square, 4. Minus 2, 2 by 2. Right? 2 power 1. 2 power 1 is not 8. That's why eliminate this option. Which option is correct? Third option is correct. Understood? Now, this is first method. Using the options. Sorry, if options are not given, I am explaining. I am coming to that part also. Okay, Avdesh. If options are not given, what is conventional model? I am explaining. That's why I said I am going to explain 2 methods. First method I have completed. Now second method. Observe now. To understand second method, what is symmetric? What are the entries of symmetry? You must have an idea. Okay, concentrate. A is n cross n matrix. N cross n matrix. Sir, n cross n matrix means how many elements we have in n cross n matrix? In 2 cross 2 matrix, how many entries we have? 4 entries. If n cross n matrix, how many entries we have? N square entries. So total number of elements are n square. Okay. Now, sir, how many entries in the principal diagonal? How many elements in the principal diagonal? Number of elements in the leading diagonal are four. N. Okay. N. Okay. Now, sir, why you are writing leading diagonal? I require symmetry. That's why. Total n square entries. In the leading diagonal, you have n entries. Now, in the leading diagonal, you have n entries. Subtract. If you subtract, n square minus n entries will come. So these n square minus n entries are above the leading diagonal and below the leading diagonal. Please remember, this is the main point. In a symmetric matrix, all the off diagonal elements must satisfy the symmetric condition. Okay, this is leading diagonal. All the entries above the leading diagonal and below the leading diagonal must satisfy the symmetric condition. Sir, what is symmetric condition? A12 and A21, A13 and A31, A14 and A41, Aij and Aji must be equal. That's why total n square minus n elements. Now, because of symmetry, I am going to write these are all remaining entries. These remaining entries must satisfy the condition of symmetry. That's why I am going to write because of symmetry. I am writing n minus n square minus n by 2. नरेंद्र थोड़ा सोचना पड़ेगा आपने. ये प्रॉब्लम सिमेट्रिक के बारे में दिया ना, क्यों सिमेट्री ले लिया? उन्होंने दिया इसलिए हमने ले लिया. Problem is designed on symmetry. That's why we are going to take symmetric condition. Okay, come to the problem. N square minus n by 2 because of symmetry. If you have 4 entries are here, same 4 entries you must have here. That's why to satisfy symmetric condition, I have divided by 2. Okay, now concentrate. Sorry, if you take only n square minus n by 2, you will get only the entries above the leading diagonal. Sir, what about leading diagonal? Compulsory I have to add. Therefore, total number of independent entries means distinct blank places. So total number of independent entries equal to n square minus n by 2 plus n. These n square minus n by 2 are the entries which are above the leading diagonal or below the leading diagonal, because both above the leading diagonal and below the leading diagonal are following symmetry, plus this leading diagonal. That leading diagonal is nothing but m. Okay, now add. How many distinct blank places you have, you will get here. Denominator is 2, numerator is n square minus n plus 2n. Okay, 2n minus n square plus n by 2. If you simplify this, you will get n square plus n by 2. Sir, what are these n square plus n by 2? These n square plus n by 2 are distinct blank places. I am talking about blank places, distinct blank places. Now, first place, second place, third place, like that, n square plus n by 2th place. First place, second place, third place, n square plus n by 2th place. Now, each place you can fill either with 0 or with 1, 2 ways. Either with 0 or with 1, 2 ways. Either with 0 or with 1, 2 ways. 2 ways. Now apply fundamental counting principle. 2 into 2 into 2. How many times? N square plus n by 2 times. That's why 2 power n square plus n by 2. So total number of distinct symmetric matrices are 2 power n square plus n by 2. Understood? This problem requires logic. Okay, Now, if you could not get second method, you follow first method. Raju, leading diagonal entries are n entries. Those n entries are n different blank places. I am talking about place, different blank place. Raghav, there are numerical answer type in GATE exam, MSQs in GATE exam, MCQs in GATE exam. Concentrate on the content. If you have the content, you can write whether what type of problem is given. Now, observe this problem. Yesterday I have explained you clearly the speciality of orthogonal matrices. Orthogonal matrices. Okay. A into A transpose equal to I. That is standard definition. I have explained some properties of orthogonal matrices. Orthogonal matrix is collection of orthonormal vectors. Sir, what is orthonormal? What is orthogonal? Yesterday I have explained you. Okay. Now, based on that hint, you try this problem. Given that the matrix is orthogonal matrix, if the matrix is orthogonal matrix, what are the values of alpha and beta? I am reducing the time, only I am giving 90 seconds. How you are getting the answer in 1.5 seconds? At least calculation requires minimum 2-3 seconds. That means you remember the answers. Okay, morning you have solved. Okay, very good. Okay, Vikash. Very good. Mr. Akhtar, in the first method, how A12 and A21 are same means it is a symmetric matrix. That's why Aij and Aji are same. Okay. Now come to the problem. In this problem, matrix is orthogonal matrix. Orthogonal matrix is combination of orthonormal vectors. That's why apply the orthonormal conditions. I am taking columns. First column and second column are orthogonal. Second column and third column are orthogonal. That's why I am using the conditions C1 transpose dot C2 equal to 0, C2 transpose dot C3 equal to 0. Okay, when you take columns, first column transpose, row multiplied with column gives us 1 cross 1. That's why I have taken C1 transpose dot C2. Suppose if you take R1, R2, you have to write R1 dot R2 transpose equal to 0. Okay, now come here. C1 transpose. 1 by 9, 8 by 9 and alpha by 9 dot C2 equal to 0. C2 is minus 4 by 9, 4 by 9, minus 7 by 9. Multiply minus 4 by 81 plus 32 by 81 minus 7 alpha by 81 equal to 0. You can take C1, C3, no problem. Now 28 minus 7 alpha equal to 0, alpha equal to 4. Next, C2 transpose dot C3 minus 4 by 9, 4 by 9 minus 7 by 9 dot 8 by 9, 1 by 9, beta by 9 equal to 0. Multiply row with column. Minus 32 by 81 plus 4 by 81 minus 7 beta by 81 equal to 0. Minus 28 minus 7 beta equal to 0. 7 beta equal to minus 28, beta equal to minus 4. Alpha is plus 4 and beta is minus 4. Understood? Therefore, correct answer is third option. Hello, Aniket. Aniket, please understand what is the difference between matrix and vector. I have explained you orthogonal matrix is combination of orthonormal vectors. I never said orthonormal matrix. I said orthonormal vectors. You can take R1 transpose dot R2 also. Resultant matrix must be 1 cross 1. That is called inner product. Sir, क्यों नहीं R2 transpose dot R2? You can take, man. Result must be 1 cross 1. Like that you have to take. Sir, why you have taken C1, C2? It is very convenient. Only one unknown you have. If you multiply like this, one unknown value directly you can get. Suppose if you take R1, R2, R2, R3, you will get two unknowns in one equation. So you have to solve two equations. After that, you have to get the values. That's why I have taken columns. Okay. Rakesh, you can use magnitude 1 logic also. I have given so many properties. You can use any method. A into A transpose equal to I also you can take. You have to multiply 9 entries. Concentrate here. Observe this problem. Excellent problem, this one. For the matrix ABC, BCA, CAB, Abhishek, 1 cross 1, inner product must be 1 cross 1. Dot product of two vectors must be constant or not? थोड़ा सोचना पड़ेगा. टू वेक्टर्स को डॉट प्रोडक्ट लेने हैं तो आपको कांस्टेंट मिलेगा नहीं मिलेगा? Observe. Concentrate here. The given matrix satisfies this condition. A transpose into A is equal to I. Please remember, A transpose into A equal to I or A into A transpose equal to I. The matrix is orthogonal matrix. Orthogonal matrix. Understood? ABC values are unknown. We don't know. They have mentioned that ABC are positive real numbers. Okay. And ABC equal to 1. ABC equal to 1. Then the value of A cube plus B cube plus C cube is, please remember, you have to recall formulas of algebra. Formulas of algebra means you might study formulas of algebra in 8th standard. A plus B plus C whole square. A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Okay. If A plus B plus C equal to 0, A cube plus B cube plus C cube minus 3ABC. Okay. A cube plus B cube plus C cube is 3ABC. All these formulas you have to recall to solve this problem. Okay. I am explaining one by one. Concentrate here. First, what is given in the data? First, you have to concentrate on what is given. Given that A into A transpose equal to I. Given that A into A transpose equal to I. Concentrate here. How I am processing the data. You observe keenly. A into A transpose equal to I. Therefore, matrix A, ABC, BCA, CAB is an orthogonal matrix. Orthogonal matrix. Okay. If the matrix is orthogonal matrix, we have two properties. The given vectors are orthonormal. That means A square plus, therefore A square plus B square plus C square equal to 1. Shubham, you are thinking about symmetric, na? That is unnecessary concept. You are wasting your time. That's why I said concentrate on the correct thought process. To confuse you, they might give symmetric. Okay, you are roaming there. You are going to waste at least 1 minute time there. Not required. Main, you have to focus on how to solve the problem. What is the correct condition to solve the problem? A into A transpose equal to I. That gives so many results. Length of each vector is 1 because orthonormal matlab length must be 1. That's why square root of A square plus B square equal to 1. Therefore, रूट लेने हैं तो ले लो, बाद में स्क्वायर लेना पड़ेगा फिर. Length of each vector must be 1. That's why A square plus B square plus C square equal to 1. Okay. Now dot product between two vectors equal to 0. Therefore, you can write another point. AB plus BC plus CA equal to 0. Okay. Already I have explained step-by-step procedure here. That's why I have written direct step here. Okay. Now you have two equations. One equation is A square plus B square plus C square equal to 1. Another equation is AB plus BC plus CA equal to 0. Just by one hint, we got two equations. Just by one hint. Matrix is orthogonal matrix. That's why you got two equations. You have to use these two equations to solve the problem. Okay, now I already told you one formula you have is a plus b plus c whole square ka formula. Okay, observe a plus b plus c whole square equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay, now who has written 1 and 2 are equal? Now a plus b plus c whole square equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. From this, a square plus b square plus c square plus 2 of ab plus bc plus ca. Now a square plus b square plus c square equal to 1. That's why I am writing here 1 plus ab plus bc plus ca equal to 0. That's why I am substituting 0. This is 0. Okay. 1 plus 0, that is equal to 1. So a plus b plus c whole square equal to 1. Sir, a plus b plus c whole square equal to 1 matlab a plus b plus c equal to plus or minus 1. Yes, your logic is right. But I am considering only plus 1 because in the statement it is given that a, b, c are positive real numbers. If a, b, c are positive real numbers, if you add 3 positive real numbers, you will get only positive real number. That's why I have written 1 only. Understood? Called it equation 3. Problem is not completed. Only 50% of the problem is completed. We got one conclusion, that is a plus b plus c equal to 1. Next, I am writing here, since a, b, c are positive, understood? Since a, b, c are positive, that's why I have taken only 1. I have not considered minus 1 because a, b, c are positive real numbers. It is not my assumption. It is given in the data. Okay? Next, observe. Next, hello, क्वेश्चन में a cube plus b cube plus c cube equal to 1 नहीं दिया बाबा. Our job is to calculate that value. Our job is to calculate a cube plus b cube plus c cube is what? So many visiting professors are here. Please watch the recorded video of yesterday's lecture. Complete matrix theory is interlinked. Now observe, a cube plus b cube plus c cube minus 3abc equal to one formula we have, a plus b plus c multiplied with a cube plus b cube plus c cube minus ab minus bc minus ca. Okay, a cube plus b cube plus c cube minus 3abc equal to a plus b plus c multiplied with a square plus b square plus c square minus ab minus AB minus BC minus CA. Okay, now concentrate. A plus B plus C value is 1. It is given in the data. Not data. We calculated from equation 3. I will write here from 3. Next, A square plus B square plus C square value is 1. From equation 1, from 1, AB plus BC plus CA value 0, 0. That's why bracket begin 1 into 1 minus 0 is 1. Okay. Now AQ plus BQ plus CQ minus 3ABC equal to 1. We got. Now we have to calculate AQ plus BQ plus CQ. AQ plus BQ plus CQB is 1 plus 3ABC. Now 1 plus 3 into ABC equal to 1. Sir, how ABC is 1? It is given in the data. Given that ABC equal to 1. That's why 1 plus 3 equal to 4. Final answer is 4. Okay? Got it? Chandani, how I have taken 1 and 2, equation 1 and equation 2 are obtained from the orthogonal matrix. If the matrix is orthogonal matrix, length of each vector must be 1. That's why I have written 1. Okay. Dot product between R1, R2, R2, R3, C1, C2, C2, C3 equal to 0. That's why I got equation 2. That concept I have explained yesterday. Okay? Right. Siddharth, if there is any other approach, any shortcut approach, definitely I will discuss. Okay? The other approaches has some problems are there. Some students will start A into A transpose equal to I logic, or determinant value of A equal to plus or minus 1. Then you have two possibilities will come. Whenever two possibilities comes, 90% of the students get confused and they commit the mistake. That's why I preferred only this approach. Sarthak, determinant value of A is not mod 1. In the case of orthogonal matrix, determinant value is either 1 or minus 1. Okay? Next problem. This is another problem. You have to apply little bit. This one. First, understand the data. If you understand the data, you can able to solve. Main thing is understanding the data. Raju Kumar, डॉट प्रोडक्ट नहीं लेने हैं तो ट्रांसपोज तो मल्टीप्लाई करने हैं तो कर दो, कोई दिक्कत नहीं. If you do like that, it consumes time. That is the only thing. Okay? You multiply, you take dot product, A into A transpose equal to I, multiply 9 elements, 9 equations will come. It will increase another 10 minutes time. Okay? Concentrate. First, understand the data because it is given in set builder form. Generally, to represent sets, you have two forms. One is roster form, another one is set builder form. So it is not in roster form. Roster form means list all the entries of the set. Okay, so it is in set builder form. How you are understanding the data is the matter. in this problem. First, I am explaining what is given in the data. Whether 25 or 125 or 625, we can decide later. Okay, I'm not interested about the answer. I'm interested about the concept. Okay, concentrate now. Let S. Sir, what is S? First question, what is S? He has mentioned flower bracket here. Visible or not? I'm explaining one by one. Observe. There is a flower bracket. While I'm explaining, concentrate. It is very difficult to understand. Very difficult to understand. That's why concentrate. S is a set. Sir, how do you know that? They have given flower bracket. Okay. Based on this flower bracket, we can understand that S is a set. Set means a well-defined collection of objects is called set. Sir, what is entry in the set? Element. Sir, what is element in the set? He has mentioned A, such that. So, all the elements in the matrices are capital A. Sir, what is capital A? Capital A is a matrix of order 5 cross 5. So immediately you have to understand that, okay, this is a set of all 5 cross 5 matrices. It is a set of all 5 cross 5 matrices. Sir, all set of 5 cross 5 matrices means what are the entries of the matrix? That point also he has discussed here. Every entry of the matrix is either 0 or 1, or for all. This is the symbol for all. So all the entries of, it is not 1 5 cross 5 matrices, it is a set of 5 cross 5 matrices. The set consisting different 5 cross 5 matrices. So in that 5 cross 5 matrices, every element is 0 or 1. That is first condition. This is 5 cross 5 matrices is first condition. Every entry must be 0 or 1 is second condition. There is third condition. Come here. This is third condition. Sigma ai is a equal to 1 for all j. Sir, sigma ai is a equal to 1 for all ij means, for all j means sum of, sigma represents sum of all entries in a row equal to 1, sum of all entries in each column equal to 1, sum of all entries in each row equal to 1, sum of all entries in each column equal to 1. Sir, you have mentioned that every entry is either 0 or 1. Every entry is either 0 or 1. Sum of all entries equal to 1 matlab, if you have n entries in a matrix, if you have n entries in a row, in that row, how many entries are 0? n minus 1 entries are 0. n minus 1 entries are 0. Only one entry is 1. Understood? Catch my point? So, the problem is very simple. Concentrate. If you understand, very simple. I am repeating. Your matrix, your set is, Abhishek, first you concentrate. You have 4 conditions. Your set is consisting of different matrices. Your set consisting different matrices of order 5 cross 5. That is first condition. Second condition, all the matrices are distinct. In the distinct matrices, every entry is either 0 or 1. Third condition, if you add all the elements in a row, in each row must be 1. If you add all entries in each row, the sum is 1. So sum of all elements of first row is 1. Sum of all elements of second row is 1. Sum of all elements of third row is 1. Sum of all elements of first column is 1. Sum of all elements of second column is 1. Sum of all elements of third column is 1. Like that. Sir, sum of all elements of one row equal to 1 matlab only one entry 1, remaining all entries are 0. Yes. One entry 1, remaining all entries are 0 in each row and each column. That is the condition. Okay. Now summation notation क्या explain करेगा बा? Summation notation is sigma. Sigma I मतलब sum of all elements of a row, sum of all elements of a column. J मतलब प्रिंसिपल डायगोनल एलिमेंट के बारे में कुछ भी नहीं दिया. He has not mentioned principal diagonal entries. He has mentioned 4 conditions. All the 4 conditions I have explained you. Okay. Now, how many number of elements in set S? Sir, how many number of elements in set S? Matlab, every entry is a matrix, na? So, how many different matrices in set S? 25 or 125 or 625 or which one? I would like to explain. Concentrate here. Please observe. Any such type of conditional problem is given, you just take 2 cross 2, then 3 cross 3, then estimate n cross n. Okay, come to the problem. That is the best method. Tata roster format matlab I am going to write, you observe. Suppose your matrix Aij is 2 cross 2, set S consisting of all 2 cross 2 matrices. All 2 cross 2 matrices matlab distinct 2 cross 2 matrices. Distinct 2 cross 2 matrices. Concentrate. Every entry of your matrix must be either 0 or 1. Sum of all elements of each row equal to 1. That's why one entry is 1, remaining entries are 0. One entry 1, remaining entries are 0. 0, 1, 1, 0. These are the 2 different matrices of order 2 cross 2. So how many? 2. Later I will come to 2. I have written 2. Whether 2 or 2 factorial, we can decide after calculating 3 cross 3. Okay? Observe. Set S consisting of distinct 3 cross 3 matrices now. Mr. Akhtar, whether answer is 2 or 2 cross 2 or 2 factorial, we can decide later. You did not understand. Distinct matlab different man. Chandani, Sinha, distinct matlab different. Chandani is different from Nitya. Nitya is different from Janaki. Okay. Distinct matlab different. Come to the concept. I have to write different 3 cross 3 matrices. Concentrate. Mukul, you have to take entries only 0 or 1. Okay? Now, come here. How to write different matrices? I am explaining now. First row, I have fixed 1, 0, 0. 1, 0, 0. Here also I am fixing 1, 0, 0. Okay. Remaining 2 rows, I am going to change like this. 0, 1, 0, 0, 1, 0. 0, 0, 1, 0, 0, 1. Observe now, different matrices are not. Two different matrices are not. Every entry is 0 or not. Sum of all entries of each row is 1 or not. Sum of all entries of each column is 1 or not. Now, observe. Now, I am fixing 0, 1, 0 here. 0, 1, 0 here. 1, 0, 0, 1, 0, 0. 0, 0, 1, 0, 0, 1. Both are different or not? Both are different or not? Not both. All four are different or not? All four are different or not? Next, I am going to fix. You understand the logic now? I am going to fix 0, 0, 1 in the place of first row. Now, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0. Observe now. All 6 matrices are different or not? All 6 matrices are different. All 6 matrices are satisfying the given 4 conditions. Every entry must be 0 or 1. Okay. Sum of all entries of each row is 1. Sum of all entries of each column is 1. So, in the case of 3 cross 3, you got 6 entries. 3 factorial different elements in your set S. 3 factorial different matrices in your set. That's why in the case of 2 cross 2, 2 factorial. Okay. Now tell me, if your matrix is 5 cross 5, how many distinct 5 factorial? So the answer is 5 factorial. The complexity of this problem is only to understand this set. Sir, what is set here? There he has twisted in the data. Completely problem is twisted in this set builder form. Okay. Understood? Now, there is no other general method, only permutations and combination method or this arrangement method. To understand permutations and combinations, how to fill 0 or 1? Hello, 0 or 1 is given, not 0 and 1. I am talking about 0 or 1 only, Baba. I never said 0 and 1, Mr. Mukul. I never said 0 and 1. I said 0 or 1 only. Okay? Last वाला summation को, last वाला में summation नहीं, entries. इधर कोई summation नहीं, only entries, distinct entries, distinct matrices. Okay. Now, determinant and properties of determinant. First row 5 places, second row 4 places, third row 3 places, fourth row 2 places, fifth row 1 place. Like that, you have to arrange. Concentrate. Now, you can fill these blank places 5 ways. Okay, after fixing one, you cannot fix in the remaining places. That's why next row only 4 ways. Next row only 3 ways. Next row only 2 ways. Next row only 1 way. So 5, 4, 3, 2, 1. If I write like this, some students may add. That's why I am going to write like this. Here 5 ways, here 4 ways, here 3, here 2, here 1. 5 into 4 into 3 into 2 into 1, 5 factorial. Okay? Now, determinant and properties of determinant. First, let me explain determinant and properties of determinant. Before that, yesterday I have explained classification of matrices based on transpose operation: symmetric, skew symmetric, orthogonal. Okay, after completion of symmetric, skew symmetric, orthogonal, we have started the problems, right? Am I right? Now in the classification we have 3 matrices. One is idempotent matrix, involutory matrix, nilpotent matrix. After that, one operation: conjugate of a matrix, transjugate of a matrix, Hermitian, skew Hermitian, unitary. After that, I'll start determinant and its properties. Okay? Now, observe. Idempotent matrix. When we say a matrix is idempotent matrix, a square matrix A is said to be idempotent matrix. A square matrix A is said to be idempotent matrix Chandani, you watched the recorded video, yesterday's video. Yesterday I have covered what basis skew symmetric and orthogonal. You watch the recorded video. A square matrix A is said to be idempotent matrix if A square equal to A. The condition for idempotent is A square equal to A. For example, suppose the matrix is 1 1 0 0. Multiply A with A square equal to A into A. 1 1 0 0 multiplied with 1 1 0 0. The result 1 plus 0 1. 1 plus 0 1. 0 plus 0, 0, 0 plus 0, 0, 1, 1, 0, 0. Again, you got A. If A square equal to A, then the matrix is known as idempotent matrix. Note, if A is idempotent, then I minus A is also an idempotent. If A is idempotent, I minus A is also an idempotent matrix. Next, involutory matrix. Backslide. Note down. If A is idempotent, I minus A is also an idempotent. I have written I minus A. Okay? I minus A. Now, involutory matrix. A square matrix A is said to be involutory if A square equal to I. If A square equal to I, note, if A is involutory, if A is involutory, if and only if I minus A into I plus A, I plus A into I minus A equal to 0. Okay. If A is involutory, then I plus A into I minus A equal to 0. 0 means null matrix. Now, for example, 0, 1, 1, 0. A is 0, 1, 1, 0. Multiply. A square is A into A. 0, 1, 1, 0 multiplied with 0, 1, 1, 0. The result is 0 plus 1, 0 plus 0, 0 plus 0, 1 plus 0. That is I. A square equal to I. Next one. Nilpotent matrix. Nilpotent matrix. If there exists a positive integer m, if there exists a positive integer m for a square matrix A, for a square matrix A of order n, both are different, I have taken. If there exists a positive integer m for a square matrix A of order n such that A power m is equal to 0, within bracket A is non-zero, A square non-zero, A power m minus 1 non-zero, but a power m is 0, then A is a nilpotent matrix, of index M. We will call it as nilpotent matrix of index M. If there exists a positive integer M such that a power m equal to 0, where a is non-zero, a square non-zero, a power m minus 1 is non-zero, but a power m is 0, then A is nilpotent matrix of index M. I'll give the example. For example, matrix A is 1 minus 1, 1 minus 1. Tell me what is index? You will get it after completion of the example. Concentrate. A is 2 cross 2 matrix. Is A is null matrix? Is A is not null? Na? Okay. A is non-zero. A is non-zero matrix. Sir, suppose A square is 0. Suppose A square is 0. Then you can say that A is a nilpotent matrix of index 2. Sir, A is non-zero, A square non-zero, A cube non-zero, A power 4 is 0. Then it is a nilpotent matrix of index 4. Okay? Now, whether 4 or 3 or 2, we have to check only by calculating power of the matrix. Okay? Now, I am calculating A square. A square. A into A. Multiply 1 minus 1, 1 minus 1 with 1 minus 1, 1 minus 1. Multiply row with column, 1 with 1, 1, minus 1 with 1, minus 1, minus 1 plus 1, 1 minus 1, minus 1 plus 1, that is 0, 0, 0, 0. A square is 0. Therefore, A is nilpotent of index 2. Don't give your innovative thoughts here. You follow the definition. Whenever A power m is 0, A power m minus 1 is non-zero, then you can say that it is a nilpotent of index 2. Okay? If A power m is 0, A power m minus 1 is non-zero, it is nilpotent of index M. Simple logic. A is not null matrix. A square is non-zero. A cube is non-zero. A power 4 is non-zero. A power 5 equal to 0. You can say that A is nilpotent of index 5. That is the meaning. Here A can be 2 cross 2 or A can be 10 cross 10 or A can be 20 cross 20. Order of the matrix doesn't matter here. Here what matters? Power. Okay? Now, next point, conjugate of a matrix. Conjugate of a matrix. Yesterday I have explained you transpose of a matrix, interchanging of rows into columns. Similarly, we have an operation known as conjugate. Actually, this operation we are going to apply on complex matrices, because conjugate is an operation which is to be applied for complex matrices. Okay? For example, a complex number a plus ib you have. What is conjugate of a plus ib? A minus ib. Okay, what is conjugate of 1 plus I? 1 minus I. What is conjugate of I minus 1? Don't say I plus 1, minus I minus 1. You have to write, you have to change the sign only for imaginary part, not for real part. Okay? Conjugate of I minus 1 is minus I minus 1. If you write conjugate of one complex number, sum of two conjugates must be real. Product of two conjugates must be real. Keep in mind. If you write conjugate of a plus ib as a minus ib, if you add a plus ib and a minus ib, sum must be real number. Product must be real number. Okay? Right. Now come to the definition. Conjugate of a matrix. Conjugate of a matrix. The conjugate of matrix A is denoted by A bar or conjugate of A and is obtained by replacing the elements of A by their corresponding conjugates. Okay, the conjugate of a matrix A is denoted by A bar and is obtained by replacing the elements of A by their corresponding conjugates. Now, example, matrix A is a complex matrix. Suppose 1 plus I, 3, 2I, 6I, 2 plus 4I, I. Sir, what is conjugate of A? Conjugate of A is A bar, which is obtained by replacing every element of A by their corresponding conjugates. What is corresponding conjugate of 1 plus I? 1 minus I. What is conjugate of 3? 3 only, because it is real. For 2I, minus 2I. For 6I, minus 6I. For 2 plus 4I, 2 minus 4I. For I, minus I. Now we got conjugate of A. Next, the definition, transjugate of A. Transjugate of A. Transjugate of a matrix. The name itself, there is a meaning. The transpose of conjugate of matrix A or the conjugate of transpose of A, both are same. Transpose of conjugate of A or conjugate of transpose of A is known as transjugate. It is denoted by A star, A power asterisk, or A power theta, or what is the meaning of that? A bar transpose or A transpose bar. A power theta or A power asterisk, it is nothing but A bar transpose or A transpose ka bar. For example, A is 2, 3 minus 4i, 3 plus 2i, 1 minus I. What about A bar? 2, 3 plus 4i, 3 minus 2i, 1 plus I. A bar transpose, that is nothing but A power theta, equal to, you have to take transpose of conjugate. So 2, 3 plus 4i, 3 minus 2i, 1 plus I. Understood? A power theta equal to A bar transpose. Next, previous slide. Transpose of conjugate, conjugate of transpose. Next, definition. Hermitian matrix. A square matrix A is said to be Hermitian matrix. A square matrix A is said to be Hermitian matrix if A power theta equal to A, that is Aij equal to conjugate of Aj for all Ij. A square matrix A is said to be Hermitian if A power theta equal to A, that is Aij equal to Aj, conjugate of Aj. For example, three, 1 minus 2i, 1 plus 2i, 8. 1 minute, observe. While writing the example, one observation you have. Two observations we have. What are the observations in that example? Principal diagonal elements are real. That is first observation. Principal diagonal elements are real. Okay. Second observation is the remaining entries are corresponding conjugates. 1 minus 2i, 1 plus 2i. 1 minus 2i, 1 plus 2i. For imaginary part, just I have changed the sign. Here minus, here plus. Okay. Now, principal diagonal elements are real. Sir, we have to maintain principal diagonal elements are always real. Mr. Pathak, it is in computer science syllabus. Every day you need not to ask, sir, ये topic syllabus में है, ये topic syllabus में नहीं है. कल बोला ना मैंने, linear algebra is common to all. Okay. Now, the main observation is principal diagonal elements are real. Sir, in Hermitian matrix, is principal diagonal elements always real? Yes. You have to maintain real. Then only you can generate a Hermitian matrix. So, first observation is these entries compulsory you have to maintain real. Okay. Yesterday we have discussed one property, symmetric. Remember, A transpose equal to A. This is A power theta equal to A. There, transpose is the operation. Here, transugate is the operation. That is real matrix. This is complex matrix. Okay, that is the difference. Just you have to recall. Symmetric is real, Hermitian is complex. A transpose equal to A, symmetric. A power theta equal to A, Hermitian. Next, skew Hermitian. A square matrix A is said to be skew Hermitian if A power theta equal to minus A, that is Aij equal to minus Aji bar for all ij. A power theta equal to minus A, that is Aij equal to minus Aji bar, conjugate of minus Aji. Now, for example, zero, 0, 1 minus 2i minus 1 minus 2i. Vivek Vardhan, I told you 2 times. Symmetric is real, Hermitian is complex. What is your question? Sir, every real symmetric is Hermitian. पागल है क्या? Real Hermitian कैसा होगा? Real is real matrix. Symmetric is real matrix. Hermitian is complex matrix. How real is complex? One is written as 1 plus IR. How 1 is 1 plus I? नींद आने है तो सो जाओ. Observe. Hermitian, skew Hermitian. So the speciality of skew Hermitian is, one minute. Saurabh, let me explain. Not only 0, but also imaginary you can take. But you have to take purely imaginary. Okay? In the case of skew Hermitian, leading diagonal elements are either 0 or purely imaginary. Purely imaginary means I, 2i, 3i, minus I, minus 2i. No real part. Real part must be 0. Okay? Like that you can take. So please remember, skew Hermitian is looking like skew symmetric, but this is complex, that is real. Here operation is transgate, their operation is transpose. Okay? Skew symmetric is different, skew Hermitian is different. You should not compare. Skew Hermitian means a power theta equal to minus a. Skew symmetric means a transpose equal to minus a. Okay? Next. Why I am comparing? Because generally students get confused. If I compare properly, you can get what is symmetric, what is Hermitian, what is skew symmetric, what is skew Hermitian, what is orthogonal matrix, what is unitary matrix. Okay? Yeah, definitely, Nandini. I'll give the examples. If you write a 3 cross 3 matrix, matrix A, 3 cross 3, here 0, 0, I have taken imaginary. Okay. Remaining entries here 1 plus 2i minus 1 plus 2i, 3i, 3i. Here 6 minus 4i minus 6 minus 4i. Understood? Here I have taken principal diagonal elements are either 0 or purely imaginary. Understood? It is skew Hermitian. Please remember, corresponding entries के लिए real part के लिए you have to change sign. You have to change sign for real part to keep imaginary part as it is. Then automatically it generates skew Hermitian. Okay. For Hermitian, you have to change sign for imaginary part. Here for real part. Okay. Right. Next, unitary matrix. Unitary matrix. This is different. A square matrix A is said to be unitary matrix A into A power theta equal to A power theta into A is equal to I. A into A power theta equal to A power theta into A is equal to I. Looking like orthogonal, but their operation is transpose, matrix is real. This is operation is transgate and matrix is unitary. Okay, it is complex matrix. Now observe, for example 1 plus I by 2, 1 minus I by 2, minus 1 plus I by 2, 1 plus I by 2. This is a unitary matrix. There is no logic and there is no hint. Just you have to follow the definition. A into A power theta equal to I. Okay. Here I have given some observations. Principal diagonal elements you have to maintain 0 or imaginary. Here principal diagonal elements are real. But in the case of unitary, you have to follow the definition. 100% Yogeshwar. A power theta is A inverse in the case of unitary. 100%. The speciality of unitary and orthogonal is a into a power theta equal to I. In general, in the definition you have a into a power theta equal to I. What is definition of inverse? A into a inverse equal to I. So a inverse equal to a power theta automatically. In the case of unitary, Shubham, here orthonormal vector, nothing. You need not apply that type of conditions. They are properties of orthogonal matrices. Orthogonal matrices. Okay. Those properties you should not apply here. Complex properties are different. Just you have to remember the definition. Okay. Now, what is determinant? What is the determinant value of a matrix? Just introduction. Generally, for 2x2 matrix A, B, C, D, what is det A? What is det A? Det A. Det A means determinant. AD minus BC. Why not BC minus AD? Why not? Is there any logic? Why only AD minus BC? Why not BC minus AD? Observe. Observe the definition. Determinant. I'll explain. The sum of the products of elements of a row or column with their corresponding cofactors is known as determinant value of a matrix. The sum of the products of elements of a row or column with their corresponding cofactors is known as determinant value of the matrix. Observe. Here, if your matrix is A, B, C, D, sir, what is the meaning of the definition? Very simple. If you would like to calculate determinant value of a matrix, what he said, you take elements of a row or elements of a column, multiply with corresponding cofactors. Suppose if you take elements of first row, you have to multiply with corresponding cofactors. If you multiply elements of your row with their corresponding cofactors, you will get products. When you multiply one element with other element, you will get product. If you multiply elements of your row with their corresponding cofactors, you will get products. Sum of those products is determinant. Sum of those products is determinant. Okay, now I am explaining. If you take elements of first row, you have to multiply elements of first row with corresponding cofactors. Sir, what is cofactor of A? What is cofactor of B? I am explaining. If you want cofactor of any element, first you write minus 1 whole power position of that element. What is position of that element? A is in which place? First row, first column. Na? So 1 plus 1. Sir, what is position of B? Minus 1 whole power. B is in which place? First row, second column. So 1 plus 2. Okay, 1 plus 2. First row, second column. Multiply with its minor. Okay, observe. A is in first row, first column. Eliminate first row, first column. What is left? What is left? D is left. Write D here. Okay. B is in which row? First row, second column. First row. What is left? C is left. Now, cofactor of B multiply A with D is minus BC. You got the products. What is your definition? Sum of the products is called determinant. Sum of the products. Add both AD plus of minus BC. AD minus BC. That is called det A. That's why it is AD minus BC. That's why it is of the product is minus BC. The result is A. So multiply with their corresponding minus C. What he said, if you take elements of a row, multiply with their corresponding cofactors. If you multiply A with corresponding cofactor, the result is AD. If you multiply B with corresponding cofactor, the result is minus BC. You got the products. What is your definition? Sum of the products is called determinant. Sum of the products. Add both AD plus of minus BC. AD minus BC. That is called det A. That's why it is AD minus BC. That's why it is AD minus BC. Understood? Only one row ka summa. It is a square matrix, Baba. If you take one row, how you are going to get square matrix? Your matrix must be square matrix. Determinant exists only when matrix is square. Okay, not for rectangular matrix. Whether it is 3 by 3 or 10 cross 10, process is same. Take elements of your row, multiply with corresponding cofactors. You will get products. Sum of those products is determinant. As per the definition, you can take any row or any column, but we have one practice. What is our practice? We use it to take first row. That is our practice. It is not compulsory. You can take any row or any column. We use it to take first row and multiply with corresponding cofactors. That is our practice. Okay. Tomorrow I'll discuss 3 cross 3, 4 cross 4, 6 cross 6, even though you have higher order matrices. Just I have given introduction of determinant. What is determinant? How to calculate determinant. Okay. Any queries? Innovative thoughts? Yeah, please check. I think next class is on Monday. Shravani. Okay. Thank you. Good night.